Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, got the last of the parts done on the driver tube, and I think you'll see in a second why I was showing you as I was building along that it becomes more difficult to see exactly where things are connected the further you get into the build. And at this point, the cathode bypass cap is kind of blocking the view of some of these other parts. So if you're curious, you can go back and watch some of the previous videos on this build. But we're going to be ready to get our trusty flute meter out. We're going to check the voltages, see if everything looks like it's lining up with my expectations. I did run this tube like 4 hours or 4.5 hours, something like that, with the cathode resistor. We ended up going with a 300 ohm resistor to kind of bias it a little cooler. It's still pretty hot. It's running at 42 watts, but the bias stayed right at 63 volts for 4 hours. And so I feel like that this is a stable combination. I know some people talk about how these things are notorious for going into thermal meltdown, runaway, red plate kind of a thing. I think having this tube socket exposed to the air so that it can help keep the tube cool is going to be very beneficial. This tube socket does get pretty hot. And later in the tweaking videos, I'll do temperature measurements and put them in a video or in the comments or with something, so I can explain to you that these things get way hotter than a normal octal socket did. That's why they're made out of ceramic. And the same thing with this cathode resistor, having as much, I think 14 watts running through it. Yeah, you don't want to run like even a 25 watt resistor, I don't think. You want to run this 50 watt one so you get some real, current handling ability. People have asked about inductive, non-inductive. I've run inductive resistors on cathodes of tubes quite a bit, and I've never personally had an issue with them. My 300B amp that I love has an inductive resistor, so is that a big problem? I haven't seen it. Is it something that's audible? Possibly. If you don't like the idea of it, I'm sure there's some sort of 50 watt, 300 ohm resistor, a thick film one or something. Somebody put in the comments. You're welcome to try that. Again, that's part of the fun of DIY. You don't have to build it exactly like I am. And who knows, this may not work out. I have no idea what this thing's going to do. I mean, this is probably the most experimental, not sure of myself amp that I've built yet. But you guys wanted to see this, and I know there's a ton of different people or a ton of different designs people have come up with to try to run these tubes. And I know this is a finicky, weird kind of tube, so here we are. So anyway, we're trying to do this on a budget with these Russian driver tubes instead of those, $200, $300 D3A tubes that are just like unobtainium. We're trying to do this on a budget. That's why we used EdCore output transformers. That's why we used this Hammond choke for the plate choke, etc. So anyway, let's get this thing powered up, check the voltages, and then put this thing on the audio analyzer suite. Okay, we got the last little bit of wiring done. It's going to be really hard to see because of this cathode bypass cap that we've put in across the cathode terminal to the ground. And then we've got our grid stopper, a 2K, that comes over to this terminal right here. That goes to the positive of an RCA jack. The ground of the RCA jack comes over and up to this ground point right here. And this is why I kind of showed you this stuff in the last video before I got this bypass cap soldered in place, because it is really hard to see. But we're now ready to power this amp up. And so we have our ground clip over here. See, we got our thing on voltage. Let me go ahead and reset this for us so it doesn't shut off during our testing. And then we want to make sure you've got this lead free where it's not going to get tangled up in anything while you're checking these voltages. First thing we're going to be checking is this terminal here will be the B+. This will be the voltage going to the plate choke of the driver tube. This is the plate of the driver tube. This wire under here is the cathode of the driver tube. And then this pin right here is the cathode of the output tube. And this is the plate of the output tube. So let's power this thing up and check our voltages against what we're expecting to see. And I don't want to run the amp too long with these tubes upside down. It's not ideal thermally for them to be run in this orientation, but it is also the only way we can really check these voltages. And so here we go. And so we'll put our lead here and power on the amp. You can see we instantly get our voltage because we have a solid state rectifier. So we're going to let this run for a minute. But while this is happening, we can see the voltage coming up on the cathode of the output tube. So it starts conducting pretty quickly. And then let's go ahead and check the cathode of this driver tube. And we're right at the 2 volts we were hoping to see. I'm going to let this run for about a minute just for all the voltages to stabilize. And then I'll run through the tests. And then we'll shut this thing off because, like I said, I don't want to run it too long with these tubes upside down. This is another place you can check the cathode voltage. So we got 61 volts. And on the plate, we got 267. And I know after this runs a while, this stabilizes a little bit higher than this. There's 62 volts. It settles down about 63 volts after it's been running for about 5 minutes, but the input tube stabilizes a lot quicker. We have just under 2 volts. We have 217. We come over here, and this is on the other side of the plate choke. We have 256. Earlier I had the amp on its side and ran it for about 5 minutes, and this finally stabilized to at 255, and this was 275. And then this stabilized right at 2 volts. It's 1.9 right now, but after the tube gets good warmed up, it goes up just a breath. And then let's see what we've got over here. We've got 266. And then on the cathode, we have 63.5. And like I said, after it runs for a while, this stabilizes down to 63 volts. So all these voltages, let me go ahead and turn it off. All these voltages are well within the expected voltages from this circuit design. We have approximately 20 milliamps running across the input tube, which comes out to like 4 watts at the voltage it's running at. And we've got approximately 42 watts across the output tube, which is under the max rating of 45, and I feel comfortable running this tube there. So all our voltages came out great. And at this point, I'm ready to hook this thing up to the audio analyzer suite and see what this thing does with a signal running through it. Well, here we go. We've got the amp hooked up to the Analog Discovery 2, and we're fixing to do our first pull on it. This is with the 6J52P tube in the amp, and let's see what this thing does. And this is not looking good. This is why I tell you, don't build things along with me, especially something that's an experimental prototype. And yeah, that's a ton of distortion. This is not what we were looking to see. You can see we're out of the gate at almost 1% distortion at, what, a quarter of a watt? It's going less than a quarter of a watt, it's going past 1%. And here at 1 watt, we're at 2.5%. And at 3 watts, we're at 5%. Yeah, this is not going to be usable like this. The only thing I can say that looks sort of promising is this is a straight line. Normally when I've built these amps or different single-ended amps with a plate load resistor versus a plate choke, when you get near the end of the power spectrum, the curve is more logarithmic. It's like it'll stay down low and then it curves up at the very end, where this is staying pretty linear across the whole range. So one of the things I want to check for is to see if there's something weird going on with the frequency response that's causing the same issue. So let's go ahead, and I want to make sure we're pulling it at about a watt, which is 2.5% distortion, and that would be 0.2 volts RMS. And I can see the input sensitivity is pretty high. We're getting 10 watts of power out of 0.6 volts RMS in, which is going to be a pretty sensitive input, which can be a good thing, and it means it'll be super easy to drive. But yeah, this distortion is not acceptable. So let's take a look at the frequency response curve and see what that looks like, and see if that may be what we're seeing. So again, since it's a monoblock, we're checking one channel, and here we go. Holy cow. That is some seriously good low frequency response. Now again, we're only checking at 1 watt of power, but down here at 20 hertz, it's like 0 dBs of roll off. And even down here at 10 hertz, it's only a little over a quarter of a dB. Now we do have some roll off here on the higher frequencies, which we'll need to try to address. If you look at that left number in orange up there, we got basically 0 dB, and when we got to 10K, we're about 1 dB down, and then at 15K, we're close to 2 dBs down, which seen amps roll off like this on the top end. We can look at what's causing that, but here on the low frequencies, that's some seriously good low frequency response. And I'm actually curious what it would be at these higher distortion levels. Let's go ahead and put in 0.6 volts RMS and see what the frequency response looks like. Looks like we got the same frequency response curve even at the higher power level. So that's really impressive. So I don't think there's some kind of bandwidth problem with this choke, or we wouldn't have this sort of flat frequency response curve. And again, I'll do some research to try to figure out what's going on here, see if we can extend this high frequency response a little bit. But yeah, there's just rock star low frequency response. So let me go ahead and swap in this 6J11P tube, which is a 4.5 watt version of this type of pentode that we triode strapped, and see if maybe that's what's causing this high distortion. So I just swapped in this 6J11P-E, and again, I don't know what a D3A would do in this amp, but I just have a hard time paying $200 for a signal tube and to design an amp around a tube that's that expensive. So I'm going to try to figure out how to make these inexpensive Russian driver tubes work. And I bought a box of like 20 of these 6J11P tubes for 25 bucks or something, super cheap. And so these are definitely easy to get. They look like new old stock tubes. I don't think they've ever even been used. And if I can make the amp work with those, we'll actually have something cool here. So let's do another pull, changing out the driver tube, and see what that does. Guys, this looks like identical to the previous pull, which in my opinion we should be seeing something different when we swap out tubes that are this different. And there's nothing. It's still got this nice flat, or not flat, but linear line here on the distortion profile, but yeah, that's just a ton of distortion. And that's leading me to the belief that maybe this choke just isn't up to the task of being a plate load choke. I mean, it's listed on the Hammond site as being a power supply choke, and possibly, I'm new to this whole plate choke thing, that maybe you really do need a very specific winding or type of choke to use on the plate of a driver tube to get good response, and possibly all this distortion I'm seeing is related to using a choke that really wasn't designed for this. I mean, the same thing can happen if you try to use like a power transformer as a output transformer. Even if they measure identically doing external measurements, that when you're putting them into the actual circuit and driving a signal through them, they just don't perform. And why different output transformers that have the same impedance rating and wind ratio perform highly differently, just based on the core material and how the windings are done and interleaved and all that kind of stuff. So yeah, this Hammond choke may just be junk, and we need to punt, go back to, I don't know if the drawing board, or maybe back to the part source list anyway, and try to figure out something to use in its place. But I do have an idea of how we can single out this choke being the problem by using a plate load resistor in place of the choke, and seeing if we see a change in the distortion profile, which would, at least to me, lead me towards that the choke is what's causing all this distortion. So yeah, let me go do that. We'll come back and do another test. And so I decided to replace the choke with a plate load resistor. And given that the DCR of this plate choke was 2.2K, and the circuit was kind of designed around that resistance value, I decided to try a 3.3K resistor. And don't ask me why, it just seemed like that might be a good value to start with. So we have the 6J52P driver tube in the amp, and we're going to do a pull on it to see what we get, and already the distortion's much lower, at least at the low end of the scale. Now this still isn't what I would want to see, but it appears to be pointing in the right direction, that maybe this choke I'm trying to use just isn't a good one for this use. And you know, this time, again, we're going past 1% distortion at a half a watt, but before we were starting out at 1% distortion down here all the way on the end. And it does ramp up here fairly steeply, but I feel like we're moving in the right direction. So next, I want to try a 6J11P. So pop one of those in the amp, and again, this is with a 3.3K plate load resistor. And we're going to let this tube warm up a little bit, and then do a pull on it and see what kind of results we get using this as our driver tube. And holy cow, look at the difference that this makes. This is actually looking really good. Now it does require higher input voltage to get to this same power level. So this does mean the input sensitivity is a lot lower. So it's going to take a higher powered preamp, like here at the top end where it's going past 5% distortion. It takes 2 volts RMS to get there, but we're seeing almost 12.5 watts. And then if we look down here at 1% distortion, we're right at 4 watts. There we go, see? I'm right at 4 watts. And then at 2% distortion, we are right at 7.5 watts. So this is starting to look more like I was expecting to see on our first testing. And this is telling me that there's something going on with this plate choke, that the output tube circuit is fine, that it's not where this distortion's coming from, that the distortion's being caused by this driver tube. And so it's time to punt and do some more research on this plate choke thing and try to figure out what's going on and what we need to do on redesigning this amp to get this sort of performance and hopefully lower the input sensitivity down some, because it is still quite high. And hey, if this is what we end up with, I'm not crying about these results. I do find it interesting that switching from that 52p tube to this 11p tube made this much difference. And I did do the calculations with the plate dissipation and voltages and all that stuff, and we're running this tube at 4 watts and it's rated at 4.5 watts. So we are under the dissipation level for this tube, and I have read that this tube really likes to be run hard, and that may be the difference between the 52p and this 11p, that the 52p being a 10 watt tube is just coasting along, and possibly if it was run closer to its 10 watt rating that we'd get the same sort of distortion profile. Not sure. But anyway, this looks like a good spot to wrap up this video. Well guys, this didn't work out as ideal as I was hoping it was. Hopefully this choke is what's holding this thing back, and that this choke that's sold as a power supply choke, I mean, I saw the 200 Henry 30 milliamp, I thought, hey, that looks perfect. But I think there is more to a plate choke than just the actual stats. And I think, like I said, same thing with output transformers when you're dealing with audio signals, that just the numbers aren't enough. Or at least I'm hoping that's what it is. So I've got a viewer that I think he goes by Panhead Chopper is his handle, maybe on YouTube. Anyway, that's his email. But anyway, been talking to him about this, and he was saying that he's got a pair of 1668 15 milliamp rated Lundell chokes, plate chokes. They're made for this, and they're like the dual coil that act kind of like humbuckers with a opposite or whatever. They're made for this actual application, and he's going to send me a pair of those to try, and they should be here in the next day or two. I'm not sure exactly when I'll get back to working on this, but I do feel hopeful after seeing the results when that 6J11P-E tube and the 3.3K plate load resistor, that there was at least decent THD performance, which makes me think we've got the output tube and the output transformer and that operating point and the cathode bias and all that. Don't think that's the problem. I think it's over on this side of the amp with, you know, the driver tube and this plate choke and something and all of that that's just not playing well together. And like I've warned you, hopefully people hadn't been building this thing at home as I'm doing this, because, you know, who knows, I may end up throwing this chassis away and doing something totally different. I have plugged this thing in and listened to it, and I didn't hear any hum. And so I don't think that's going to be an issue like some people were saying it was going to be. And I tried it both with the plate choke and with the plate load resistor. And I will say with the plate choke, I heard a little bit of hum. I mean, I had to put my ear up to the speaker, but then when I put the plate load resistor in it, that was gone. And so I think that may be part of the issue too with this plate choke that I'm using, this Hammond one, that's really made for a power supply, that it's not going to cut it as a plate choke or an anode choke. So we got some nice ones of those coming, and yeah, it's probably going to take some playing with this. I may have to go to a LED bias on this front end tube. I haven't ruled that out. I saw one guy talking about, this guy Andy on DIY Audio, which has played with plate chokes a lot, saying that he doesn't bypass the cathode resistor when he's doing the plate choke deal. And so that may be part of the magic. But yeah, this is going to take a while to sort out. And honestly, I've got some other things on my plate. I know this is going to disappoint some of you guys, but this thing may get put on the back burner for a few weeks while I finish up that music share. I do have another tape deck that I want to go through. I've got some other stuff that I need to look at. Plus, I've promised a couple of phono stages. I know I said I wasn't going to build any more production stuff, but I got two people begging me for a phono stage, and I've got most of the parts here, so I kind of need to finish that up. And getting a little income for the end of the year is not going to be a bad thing for me. And so, anyway, I appreciate y'all's patience on this. I think this is going to be a cool project. It's turned out to be a lot more work than I expected, and especially now, yeah, I don't want to say I'm like disappointed, but yeah, I'm kind of disappointed. I was hoping this was just going to like plug in, maybe swap in some different driver tubes or something, and it was going to just work. And yeah, that's clearly not the case. But I'm learning. I hope you're learning. That's the fun of this to me, is we're all learning stuff here. And like I've said before, I know some of you guys think I'm trying to come off as like this tube guru that knows everything about this stuff. I absolutely don't. And to me, a lot of this stuff is still trial and error. And I know some folks love just simming things and think that's the solution to everything. Simming this Hammond plate choke versus the Lundell choke, you're not going to be able to do that. And the simulator may say the plate choke works great because the model is a perfect choke, but that doesn't exist. And so a lot of this is trial and error to learn what works and what doesn't. And when we get to the end of this, hopefully we'll get a really nice running version of one of these guys for you to build. We'll give you a heads up. This is one seriously hot running amp. You do not want to build this thing and plan on using it in the summer unless you live in Antarctica. This tube puts off an insane amount of heat, and I'm only running one of the heaters. I can't imagine what this thing's like running both the heaters. You couldn't get anywhere near it, or it could heat the room in the winter for you. So yeah, just a heads up on that. That's part of, the issue with this thing is, yeah, it runs on pretty low voltage, but it's got a ton of milliamps going through it. It's got over 200 milliamps going through it. And it's got these really high amperage heaters because the plates are super thick on this thing. And so, yeah, that's a whole other deal that you need to know, that this is not like a KT88 or a KT120 or, any of those other tubes made for audio. It makes a crazy amount of heat. So, anyway, hope you're enjoying this series. If you're enjoying it, please subscribe to the channel. Please like the video. Thanks to all you Patreon supporters, you other folks that support the channel in other ways. Got viewer that's sending me some chokes to try to sort this amp out. That sort of thing just means a lot to me. And some of the emails and comments y'all make some of the uglier stuff worthwhile or easier to put up with. So, until the next video, have a nice day.